So here's going to be multiplication and division of two complex numbers. So let's say you have two different complex numbers in polar form, or they cannot be in polar form and you have to go ahead and put it in polar form. Then what's going to happen is that if you have if you have the multiplication of the two of them, you don't have to multiply the complex numbers. If they're already in polar form, then all you really have to do to multiply them is multiply their r values together. And then for the cosines, just add the angles together. Okay, same thing with the sines. Just add them together for multiplication. So this is in case you want to multiply two different complex numbers. If you want to divide two complex numbers together, then you're going to take the r values and you're going to divide them. And instead of adding the theta values, you're going to subtract them. So I'm not going to prove these for you, but it's very easy to prove. Just basically brute force, multiply these two together, FOIL everything out, and you're going to be able to see the sum and difference formulas in there. So we won't do the proof. We'll just jump into an example on how to use these formulas. So what I want to do is multiply by converting to polar. So let's say z1 here is equal to 1 plus I. So clearly here, these two complex numbers are not given to you in polar form. Okay, so we're going to have to do a little bit of work with that. So, and then what you want to find z1 times z2. And then later on, you want to find, let's say we want to find z1 divided by z2. Okay, so now the first thing that we're going to do is that we need to convert these guys to polar form. So for z1, the first thing that we want to do is figure out what the r value is. So for z1, let's figure out our r. So r is going to be equal to the square root of 1 squared plus 1 squared, which is going to be square root of 2. Okay, the theta value is going to be equal to the inverse tangent of the division between those, which is 1 over 1. Notice that we've already solved this one. This is pi over 4. So it makes sense for this guy to be pi over 4 because it's in quadrant 1, just like how we did it in the previous one. So what that means is that when I write it in complex form, polar form, it's going to be square root of 2 cosine pi over 4 plus I sine of pi over 4. And then same thing with z2, you're going to convert it. So r still is equal to the same thing. This is equal to square root of 2. Here, theta is going to be the same exact thing. But notice it's not going to be pi over 4 because you can see that this guy, again, is in quadrant 3. And the angle that I got was in this quadrant, so we got to add pi over. And we said that that was going to give me 5 pi over 4. So then z2 is equal to the square root of cosine 5 pi over 4 plus I sine of 5 pi over 4. So now what we want to do is we want to multiply both of these guys together. So you want to multiply z1 times z2. And the way that we're going to do that is we're going to start off by multiplying the r values together. So square root of 2 times square root of 2 is going to be square root of 4, which gives me 2. Then what we're going to do is we're going to add the pi over 4 and the 5 pi over 4. That's going to be cosine of 6 pi over 4, which is going to be 3 pi over 2. Plus I sine of adding this guy together again. That's again 3 pi over 2. So basically, when I multiply these two complex numbers together, what I'm going to get is this answer in polar form. Now, let's say you wanted to get it back into I. Well, that's going to be really easy because all you got to do is just put this in your calculator or you look it up in the unit circle. So the cosine of 3 pi over 2 is just going to be 0. The sine of 3 pi over 2 is just going to be negative 1. Okay, so then when I multiply this, you're just going to get negative 2i. So that means when I multiply these two guys together, what I'm going to get is negative 2i. You can always check your work by brute force multiplying this out straight ahead, and you'll see that that gives you negative 2i. Okay? Alrighty. So now how do we divide? So the way that we're going to divide it is now that we have them in polar form, we're just going to go ahead and just use the formula, which basically means let me divide out, let me divide out the radius, which is going to be square root of 2 divided by square root of 2. We're going to subtract now pi over 4 minus 5 pi over 4. Okay, so then plus I sine of pi over 4 minus 5 pi over 4. Okay, so what I'm going to get, let me write it down here. This is going to be a 1. Then we're going to have cosine of negative pi plus I sine of negative pi. So this guy will be the answer for the division between the two complex numbers. So now if you really want to figure out what exactly that was, cosine of negative pi is going to give me negative 1. And the other guy is just going to give me 0. So basically the answer is negative 1. So that means that when I divide these two guys up, then what I'm going to end up getting is just a negative 1. Okay, that's basically what it means. Okay, so these problems aren't too bad. We just basically have to convert them into their polar form. And then after that, we can just divide, you either multiply or divide their polar forms together.